Hello, this is Dr. James Camp from Lee College in Baytown, Texas, and these are my comments on starting out with C++ Chapter 4, Making Decisions. Okay, we're going to first, in order to make a decision, we have to be able to evaluate a truth value. Okay, is something true or is it false? And the most common kind of truth values that we arrive at in programming are comparison truth values. Is A greater than B or less than B? Is A equal to B or not equal to B? The operators that we use for this in C++ are more or less what you would be used to from writing algebraic expressions in math. Greater than and less than obviously are exactly what you would be used to in math. Instead of writing greater than or equal to and less than or equal to as a single operator, now that we have Unicode, those are available in our character sets, but C++ predates that quite a bit. So, and it's also much easier to type at a regular keyboard. Greater than followed by the equal sign, less than followed by the equal sign. Note that that and this are not valid C++. The greater than or equal to have to the greater than or less than has to precede the equal sign. Equal to, this is the one that trips everybody up. We're used to saying, does A equal B in regular parlance, but in C++, this is the assignment operator. That gives A the value of B. It doesn't test for equality. So we have this double equals operator that tests, does A equal B? So you have to keep in mind in C++, A equals B is a value assignment. A equal B is a test for equality. And then C++ defines exclamation point, the exclamation point as the not symbol. We'll come back to that later when we get to logical operators. But exclamation point equals, or bang equals, as it's often called by programmers, means not equal to. Okay? Just some quick examples of that. 12 greater than 5 is obviously going to be true. 7 less than or equal to 5 is obviously going to be false. If x is 10, x equal 10 is true. X bang equals 8 is also true because x is not equal to 8. Okay. These relational expressions can be, the result of the expression x less than or equal to y is either a true or a false result, and that can be assigned to a Boolean variable which holds the values true or false. In C and C++, you can actually assign relational results to any numerical variable, and it will assign 0 for false and 1 for true. So if I had made that int result equals x less than or equal to y, I'd either get a 0 or a 1 as my result. Okay, so now that we can ask some questions about whether things are greater than, less than, or equal to each other, we can put together if statements. An if statement allows a statement to be what we call conditionally executed. That means if a condition is true, we execute the statement. If not, we skip over that statement and continue with the program. This is one of the conditions that Alan Turing required for a Turing-complete programming language, was the ability to conditionally execute a statement. And this models the way we mentally evaluate a number of situations. If it is raining, take an umbrella. Okay. If it is cold outside, wear a coat. If you're going to the beach, put on your flip-flops. If you're going jogging, put on your jogging shoes. That sort of decision making comes up remarkably often in programming situations. Okay. We haven't really gotten into flowcharts much in this class yet, but if you look at a basic flowchart, the idea is that the basic unit of a flowchart is a rectangle containing a statement that will be executed if the flow of the program reaches that rectangle, and then flow of the program will continue on the other side of the rectangle. A very simple flowchart would look like put on a coat, open the door, step outside, and so forth and so on. Okay, and that's the kind of programs we've been able to write so far, are programs that simply do one thing after another, put one foot after another. But what if we only want to wear a coat when it's cold outside? What if we live in a place like Houston where it's almost never cold outside? Well, now we need a new flowchart symbol, and that flowchart symbol is the diamond. Okay, and a diamond represents a question that's being asked, and there are usually one input but two possible outputs, a yes and a no. Okay, in the case of is it cold outside, yes leads us to the action wear a coat, and then that returns us to the main flow of the program. No just leads us on without doing anything. It skips wear a coat. So wear a coat is being conditionally executed. It's only executed if the answer to is it cold outside is a yes. Okay, so how do we implement this? We can also have multiple statements inside the conditional branch. Is it cold outside? Yes. Wear a coat, wear a hat, wear gloves, continue. Okay. This is actually, remarkably similar to my decision process every morning. Am I going to ride my motorcycle? Yes. Put on my jacket, put on my helmet, put on my gloves, put on my boots. No, just go out in whatever I'm wearing. Okay. General format in C is if, the keyword if, okay, followed by an expression that we're going to test. We're going to test this for truth or falsehood, okay, and then a statement to execute if the expression is true. Okay. If the expression is true, statement is executed. If the expression is false, statement is skipped. Note that you have to put these parentheses here in C++. Those are not there for convenience or for looking good. They are a necessary part of the if statement in C++. Okay, so if we want to conditionally congratulate a student on getting a good score, we can write a program that says if average greater than 95, see out, congratulations, that's a high score. Okay, so here, if and only if the condition average greater than 95 is true, will we execute this cout output statement. Otherwise, the user won't hear anything from us. As in this case here, you say your average, we output your average is 80.0, but there's no output here saying congratulations, because this program doesn't consider 80 to be a grade worth congratulating, apparently. Here's what that looks like in flowchart form. Couple of notes on an if statement. Recall, an if statement looks like this up here in the corner. If expression statement. Do not place a semicolon after the expression. Okay, that is an absolute no-no. It will consider the semicolon to be the statement, the conditional statement, and it will say if expression is true, then semicolon. What does that do? Nothing. You get nothing out of that if expression. Do, for style reasons, place statement on a separate line after expression and indented. Do not leave an empty line between them, okay? So the indentation is not necessary in C++. It just makes it look nicer. It makes it readable. It's actually, I probably shouldn't tell you this for style reasons, but it's actually legal to say if score greater than 90, grade equals a semicolon, all on one line. And that's legal C++. That would compile, it would run, it would do everything it needs to do. However, most C++ programmers frown on that style. They would want you to put a carriage return and an indent there. And most C++ compiler, or most C++ IDEs these days will put the indentation in for you. As soon as you hit return after an if statement, it will indent for you to type that next line. Be careful testing floats and doubles for equality. Floating point numbers are rarely equal to each other. So if, for example, I had double x equals 1.0 over 3.0, comma, y equals 0.3333, and I said if x equals y, would that be true or false? It would be false, because there's enough rounding error between x and y that the programming, the C++, the logic unit in your computer is not going to say, well, 0.3333 is about 1/3. Sure, they're equal. C++ doesn't do that. It looks for exact equality, and exact equality is so rare with doubles and floats that it's much better to test for a range of values, and we'll cover that on a later slide. Expression, whatever expression is up here can also be replaced by a Boolean variable. Okay, so if we had a Boolean is passing, we could say if parens is passing. then print, see out, congratulations, you passed the class. It can actually be any other numerical variable with the understanding that 0 is false and any other value is true. So even -1 would be understood as true. Okay. Note that a lot of what I'm talking about here with the using non-Boolean values as true and false will not work in some of the more type-safe C family languages like Java or C#. In those languages, if you're going to use a variable to hold true-false values, it has to be a Boolean variable. Okay. Sometimes you want to do more than one thing at a time, and sometimes, we wouldn't want to say if score greater than 90, grade equals A, and then again say if score greater than 90, see out, good job, you made an A. So we can enclose the two things we want to do at the same time in curly brackets, and that links them into, as far as C++ is concerned, being one statement. Okay. The curly bracket syntax, open curly, as many lines as you want of code as you want, close curly, creates a block of code, or a code block, as some people call it. And this can be used anywhere that C++ expects a single statement. So if statements, else statements, while loops and for loops when we get to them, you can create a block of code with the curly brackets, and that will always substitute for a single line of code. Okay, if else. Sometimes we don't just want to do one thing or not. We want to do one thing or something else. We might say, if it's cloudy out, bring an umbrella, else put on your sunglasses. Okay. So the if-else expression will perform one statement if the expression is true and another if it is false. So if we had our decision block here, in this case, true leads to one execution block, raincoat, false leads to another execution, sunglasses, and then they come back together into the main program flow after that. Okay, so this would be the if side, and this would be the else side. General format of this in C++ is if expression that we want to check. Okay, statement 1 executes if expression is true. Then we put an else statement there, and if expression is false, then we're going to execute statement 2 instead. And they note here that you can use a block of code with your curly brackets instead of a statement in either of these places. Okay. So let's say we wanted to print whether a statement is even or odd, whether a number is even or odd. The easy way to test for evenness is to %2, to divide by 2 and take the remainder. If the remainder divided by 2 is 0, it's even. So our true branch gives us cout number is even. If it's false, then we had a remainder of 1, which is odd. So the else branch, cout's number is odd. Okay, and here's how that looks in a flowchart format. Another example would be if we wanted to check that division was possible because we don't want to end up dividing by 0. So enter a first number, num1, enter a second number, num2. Then here, if num2 equals 0, okay, if our divisor is 0, then we cout a series of statements that tell the user division by 0 is not possible. Else, we're going to say num2 isn't 0, so we can divide by num2, so we'll go ahead and do that operation and tell the user what the result is. Okay. We have a couple of other ways we can use if statements. We can nest them, which, if you remember old Russian nesting dolls where you open one doll and there's a smaller doll inside, and you open another doll and there's a small doll inside. You can do the same thing with if statements. You can have kind of smaller if statements within a bigger if statement if you have more than one condition that you're trying to test. For example, they use the example of a loan for people who are starting a new career. They have to be employed to get the loan, but they have to be a recent graduate to get a special interest rate for, newly employed people. So we have to test, are they employed? If the answer is true, then we have to test again, are they a recent graduate? If the answer is still true, they get the special interest rate, yay. If either of these branches are false, then they get disqualified for the loan, or at least for the special interest rate. So the way we write that in C++ is we put an if statement here, check the employed variable. If that's true, we enter this code block here, and inside that code block we put another if, and we check the recent grad condition. Okay, and if that's true, we execute what's inside this set of curly brackets. Okay, now you might be noticing that technically this outer pair of curly brackets wasn't necessary because we're only doing one statement here, an if, but it's generally kind of good form to put this extra pair of curly brackets there to indicate that this if is inside and belongs to the first if. Okay, we can also put an else there. If employed, if recent grad. Okay, if employed is true, we do this. If recent grad is true, we do this. If recent grad is false, we do this. But this is if employed, but not recent grad. If not employed, we have a different else down here. Okay. This is where the curly brackets are really, really important because they make sure that this else goes with that if, and this else goes with that if. Okay. Using proper indentation and remembering your curly brackets helps keep track of which else's and which ifs go together. You can also create a chain of different conditions using ifs and else and an if following each else, what's sometimes called an else if operation. Okay, this is for a series of conditions such as if raining, take an umbrella, if windy, take a hat. That one doesn't make sense to me. Maybe you don't want your hair blowing around. I don't know. Else, take sunglasses. So if expression 1 matches, we're going to do statement 1. Else, then we ask another if. If expression 2 matches, we're going to do statement 2, and we continue with more else ifs. If expression n matches, we'll do statement n, and then else, if nothing matches, we've got one last statement that we can run down here. If none of these other weather-specific situations come up, then walk outside in your bathrobe. I don't know, whatever the other else is. Okay. A good example of this is matching grades to, grade scores to letter grades. We start with an if. If your test score is above the A threshold, then we tell the user that it's an A. Else, if test score is B, we tell them it's a B. Else, and so on. And if they didn't match A, B, C, or D, then the final else is that your grade is an F. Know that there are a couple of really neat programming shortcuts that come out of using this else-if chain. The first is, if you match A score to begin with, you'll do C out, your grade is A, and then you'll skip over all the rest of this code and go on with whatever happens next in the program. The other is that if this doesn't match, and we go to the else, okay, I don't have to say if test score is greater than B score and less than A score, because I've already tested A score. Okay, so because this is in an else if, I know that it's not an A, so I just have to figure out if it's greater than or equal to a B. And then if that fails and I go on down, I know it's less than a B, so I only need to find out if it's greater than or equal to a C. And so we make the programming a lot more compact by doing this. You could also test for validity here. Anything greater, anything less than a 0 is obviously not a valid test score, so we could put in an extra, else if test score greater than or equal to 0, your grade is F, and else, that means the test score must be less than 0. That's going to be not even a valid test score, so we've got to catch that. I mentioned earlier that the condition inside the parentheses of an if statement can be a variable. The variable that signals a condition in the program is called a flag. Okay, this is usually implemented as a bool variable. and it's often written in a sort of with a be verb syntax, such as bool is passing. Okay, we check that the student is passing at some point. We assign true or false to that variable, or bool has permission. You know, we check the user's credentials when they log into our program, and we decide that they do or do not have permission to edit the file or something like that. Okay. Using flags with names like that makes it very easy to then write statements like if has permission, blah, 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 blah. Okay. And when you read that, that's another step to what I call self-documenting code that doesn't even need all that many comments, because it's pretty obvious what if has permission means, right? If I had named that flag good login, if good login, do this, what does that mean? Okay, so choosing good names for your variables is important. So anyway, those are flags. You can also use integers in C++ as flags. The value 0 is considered false. Any non-zero value is considered true. The problem with this, of course, as I was saying, is if you then move from C++ to programming in Java or C# or one of these more type-safe languages, it's going to require you to use a bool for that. So you need to, it's good to get in the habit of using bools for true-false variables. Okay. Once we have some logical values, sometimes we want to manipulate those expressions. Okay. You know, for example, we might, in sort of more plain English, say if light is red, and right turn, okay, then I can take a right turn on red. Okay. Or, you know, that's kind of a silly one, but if light is green or right turn, then go. Okay. So in C++, I've got light. I would have to make this light equals green. Turn equals right. Okay. But how do I implement that OR? Well, OR in C++ is a pair of vertical lines. Not the most intuitive thing in the world. And in C++ is a pair of ampersand characters. That makes much more sense to us. We're used to seeing the ampersand character mean and. And then, as I mentioned before, The exclamation point character means not in C++. And is true if both sides are true. So for this set of values that they've set us up here, 12 greater than 5, true. 5 greater than -4, true. So we've got true and true is going to be true. Here we've got true, z greater than y, that's -4 is greater than 5, that's false. True and false, if either one is false, the whole and statement is false. Okay, x less than or equal to z, okay, that's 12 less than or equal to -4, that's going to be false. Okay, y equals z, that's going to be false. If both sides of an OR are false, then it's false. Y does not equal z, so this is still false here, but y not equal z is true if either side of an OR statement is true, then the whole thing is true. Okay. What if they're both true? Still true. Okay. X greater than or equal to z. So we've got 12 greater than or equal to -4. That's going to be true. Not true is false. Okay. This is a different loan than what we were talking about earlier. Your income has to be greater than a certain income, or your employment years have to be more than a certain number of years. Okay, so we check if income greater than or equal to minimum income, or years greater than minimum years. If either or both of those is true, then you qualify. Else, we say something else. Okay. We could also say not that whole thing. We can reverse the whole if statement by making not income or years. So then we say, we give them the you must earn, else you qualify. Okay. Exclamation point has the highest precedence. So we not something first, then we and things, lastly we or things. So if you want, if red or yellow and right turn, it's going to say yellow and right turn first, then or red. If what you really meant to say was if the light is red or yellow and we're doing a right turn, then you have to put parentheses in there. Short circuit evaluation. If we can tell the value of the expression from the first expression, if we can tell the value of the whole thing from the first expression, we don't even bother evaluating expression 2. Okay, so if expression 1 and expression 1 turns out to be false, and then we get to an and operator, false and anything is going to be false. So we don't even bother evaluating expression 2. Some programmers use this actually as a handy little trick that you might include an equals sign over in expression 2 that assigns something only if expression 1 turns out to be true, or they're crazy little shortcuts that people do. Or works the opposite way. If expression 1 turns out to be true, true or anything is going to be true, so there's no reason to evaluate the other side of that statement. Okay. We mentioned earlier that it's not useful to use equals with floating point numbers, doubles and floats. So if grade is a floating point number here, well, even if grade isn't, here we're just trying to check whether it's within a range. If grade greater than or equal to 0 and grade less than or equal to 100, then we've got a valid grade. But we can also use this for, if we're trying to check that, if 1.0 over 3.0, instead of saying equals 0.3333, what we might say is if that's greater than 0.3333 minus 0.0001, and 1.0 over 3.0 is less than 0.3333 plus 0.0001. Okay, then what we've done is we've created a little range to test that your 1/3 is going to be within that. A true 1/3 value is going to be within that range. Note that algebraic notation, once again, does not work in C++. You can't say 0 less than grade less than 100. C++ just isn't programmed to make that work. Menu-driven programs can be implemented using if-else-if sequences. A menu-driven program, these are becoming kind of rare these days because most people use graphical apps where you tap on buttons and such. But it used to be that people would write programs that went, choose an option A, add 2 numbers, B, multiply 2 numbers, C, convert pounds to kilograms. I mean, just whatever your various things are, and then you'd have a little prompt, and you would type, okay, I feel like converting pounds to kilograms today, I'll type C, and it would choose, the program would then do whatever routine was necessary to convert pounds to kilograms. And you can implement that really easily by a series of if-else statements. If input equals A, blah, else if input equals B, blah, else if input equals C. Okay. Another use of if statement is to validate user input. We can inspect the input data from a user to determine whether it's acceptable, because bad output is going to produce, bad input is going to produce bad output. There's a programming statement, garbage in equals garbage out. There are a few things you can test for. Range, if you're entering a grade and it's not between 0 and 100, probably there's a problem there. Reasonableness, if you're entering a grade and it's not between 50 and 100, it might not be reasonable because people generally don't make such bad grades. Valid menu choice, if on the previous screen I had talked about options A, B, and C, and somebody typed option Z, obviously that's not valid input. Here we use if test score is greater than min score and less than max score, we do one of these things. Else, we consider the input invalid and we tell the person that they need to run the program again. Comparisons between characters and strings. Characters are compared using their ASCII values. Okay, now this little table here shows you the hexadecimal number equivalents of all the ASCII characters. So you see that numbers have lower values than letters. So if I said, is 1 less than A, I would get the answer true. Okay. Note that lowercase letters have greater values. Lowercase letters have greater values than uppercase letters. So if I asked, does A have a greater value than Z, I would find that that was true. Okay, if it's lowercase a compared to uppercase Z. So this shows I can use that to find out if something is in a, I can use that range testing that we've been practicing on the last couple of pages to look at if we're in the range from 0 to 9, you entered a digit. If we're in the range from A to Z, uppercase letter, little a to little z, you entered a lowercase letter. Else, if it's not in that group at all, you say that's not a digit or a letter. What about comparing strings? Strings are compared lexigraphically. So if I'm comparing name 1 to name 2, I'm going to compare the first 2 characters, they're the same. Next 2 characters, they're the same. Next 2 characters, they're the same. Last 2 characters, well, Y has a greater ASCII value than K, so name 1 is greater than name 2. That's true. If I asked, is name 1 equal to name 2? They're very, very close to equal, aren't they? I mean, MAR, but no, the exact string has to be the same as the other exact string. Strings that have extra characters beyond another string are considered greater. So Mary Jane is greater than Mary. This one is comparing 2 part numbers. If part num equal a particular string, then we output, if that's true, we output a particular price. Else, if part num matches another particular string, we output a price. Else, apparently our company only has 2 parts, because if we don't have S29A or S29B, it's not a valid part number. Okay. We also have something called a conditional operator. there are two ways this can be used. It can be used to create short if-else statements. So this could be one line of code. We check the condition x less than 0. That's weird. We check the expression x less than 0. If it's true, we execute y equals 10. If it's false, we execute z equals 20. That's kind of an odd way to do it. Most people don't use that for just a one-line if expression. It's much more commonly used to return one of two different values. So we would say variable var wants to get a value. We pass in test expression. That should be an S, not an X. Test expression. And then we have the question mark operator. True expression gets passed to var if that test expression is true. We have the colon operator, and then the else expression gets passed to var if test expression is false. So a good example of that is if you wanted to take the lesser of two numbers, we pass the statement a less than b, okay? Check that for truth. If a is less than b, then the lesser is a. If a is not less than b, then the lesser is b. And we take whichever of those two happens to be appropriate and push its value into the variable lesser. Okay. Note the parentheses may be needed in an expression due to precedence of the conditional operator. I have to experiment with that. This one shows you we want to charge for a minimum number of hours. So the hours that we're charging for is equal to, we check hours less than minimum hours. Okay. If we're below the minimum hours, then we're going to return min hours. If hours is greater than minimum hours, then we're going to return the actual hours. Okay. The last thing we're going to talk about, the last major topic here, is the switch statement. And this is a topic that some people leave completely out of their courses in C++ because it's not at all necessary, but it is a fun little shortcut, and it can, some people really love it. It's used to select among statements from several alternatives, so it's very similar to an if-else-if chain. It only works for variables that have discrete values like an int or a character. You can't use this with floating point numbers or string inputs because those don't have several exact values. It's very useful for menu-driven programs to, if the user types A, skip to option A. If the user types Q, skip to option Q. At first, this looks very similar to the syntax we've been practicing for other things. You say switch, you pass an expression to evaluate, and you have some curlies that define the switch statement. Then things start getting weird, okay? Instead of, well, you have these case labels, case, expression 1, then you run statement 1, case, expression 2, then you run statement 2, and here we have the special keyword break. We haven't seen this before. It's fallen out of fashion in a lot of C++, but whenever you hit break, that leaves the current loop or switch or whatever, okay? So what happened here is that if we matched expression 1, we ran through to statement 1, and then we continued on to statement 2 because there's no break. And then we hit break, and we leave the whole switch expression. Some people do that on purpose. They want to execute statement 2 every time they execute statement 1, but sometimes they want to execute statement 2 by itself, okay? A lot of times, however, this happens because somebody forgot to type break here, and so that's a very difficult thing to debug when you find out that statement 1 and 2 are always happening together, and why is that when you hadn't intended them to. You can have more than one statement here. You can have statement 1 followed by statement 1a followed by break. Okay, you can have as many statements as you want after each case label. And then at the very end, there's the option default, which gets you, if none of the other cases match, if we've fallen through, didn't match this, didn't match that, didn't match that, didn't match that, then it will, by default, do statement n plus 1. Okay, so this is a really stupid program here that says enter A, B, or C, and then whatever they typed, it tells them that that's what they typed. But you can see that that would work very well for selecting from a menu where options were A, B, and C. Okay. Expression must be an integer or an expression that evaluates to an integer, like a character, or you could have a complicated mathematical expression there that evaluates to an integer. All of your expressions must be constant integer expressions or character literals, okay? You can't have a variable as one of your cases, okay? And then the default is optional, but it's recommended to have one so that nothing falls through without doing something. How it works, your expression is evaluated, your expression is compared against all of your cases, exp1 through expn. If it matches a particular one, the program branches to that statement and continues to the end of the switch or until the break statement. And if no matching value is found, the program branches to the default. The break statement is very important. It's used to exit the switch statement. If it's left out, the program's going to fall through to the next statement and the next statement and the next statement, and your entire switch statement is going to execute. So this one, an example of where you would want to use this without breaks, Model 100 has a remote control. Model 200 has stereo sound and a remote control. Model 300 has picture-in-picture and stereo sound and remote control. So you want this one to fall through everything. Okay. If one of them didn't have one of the lower model's features, then you'd have a problem. As I've mentioned several times here, switch statement is a natural choice for menu-driven programs. You display the menu as a series of integers or characters. You know, 1, do this, 2, do that, 3, do that. Enter your choice. I type 2, get the user's menu selection as an int or character type input, use the user's input as the expression in the switch statement. So I'd say switch input, and then somewhere I'd have a case 2, and I'd do everything between case 2 and the first break statement. Okay, so that kind of sums up everything all the new material here. We want to talk really quickly about blocks and scope because we've introduced this curly bracket block syntax. Okay, a variable defined inside curly brackets has what's called local or block scope. So in this case, we have one set of curly brackets here, and I define a new variable, int years, in here. So that int years is valid until the end of this set of curly brackets, and then it goes away. It disappears. It's out of scope. There are two dangers of defining something inside a block. Some programmers like to define all the variables for a function at the beginning of the function. You have int, main, and then define all the variables you plan to use there. Other programmers like to define each variable closer to its first use because that makes the program a little more self-documenting. You don't have to put comments in as much explaining why you're defining that variable if you're defining it just before you use it. However, that can be dangerous. If you happen to define the variable for the first time inside a curly bracket block, such as an if or an else block, that's going to make it in scope only in that block, and that variable cannot be used once the block ends. So if we say if is raining number of umbrella, int number of umbrellas equals 3, and then later in the program we wanted to use number of umbrellas, it wouldn't work. It only existed inside that if block. The other danger is that C++ lets you define a new variable inside a block that has the same name as a variable outside the block. Okay, we've defined double GPA here, and then we define double GPA again inside this if block. Okay, as soon as we exit this pair of curly brackets, that inner GPA is now lost. So the whole calculation that we did inside the if bracket is lost because we had redefined GPA inside the bracket. And that's probably an error. We probably meant to use the same GPA that we had started with out there, so we just need to lose that double and reuse the GPA. But the problem is if you put double GPA inside there, it's going to be valid C++ code. It's going to compile. It's just not going to give you the results you want. And so this leads to a lot of debugging issues. Okay, here's an example of a lazy coder who couldn't come up with another variable name besides number. So they said if int number, enter the number. If number is greater than 0, then we have another int number. I'll change colors with this one. Int number, enter that number, output that number. That number ceases to exist when we exit these curly brackets, so we're back to the first number. Okay, lazy programming, bad style, don't do that. Okay, that concludes our lecture on making decisions, ifs, elses, and switches. Next up, we'll be going into loops, which are kind of like ifs that repeat over and over and over As always, if you learned something, leave me a like. And if you have something to add to the comments, go ahead and do so.